Hi children, we move on to our next chapter, chapter 5, periodic classification of elements. You might have seen the modern periodic table, the chart of the modern periodic table in your lower classes. So in this chapter we will learn more about the periodic table, but before we move on to the discussion of the modern periodic table, let us learn the early attempts at the classification of elements. We have to learn the early attempts made at the classification of elements. Actually, the earliest attempt made in the classification of elements was grouping them into two broad groups, classifying them into two broad groups known as metals and non-metals. So, the earliest attempt in classifying elements resulted in grouping the then known elements into two broad groups, metals and non-metals. But there were a few elements which showed properties of both metals and non-metals. What do you call those elements which show the properties of both metals and non-metals? They are known as metalloids. So, those elements couldn't be placed in any of these two groups. They couldn't be placed under metals because they have some properties of non-metals. We cannot place them under non-metals because some properties they are similar to metals. So, this system of classification, this earliest system of classification was rejected. So, we start with the first attempt that is made by a German chemist, Johann Wolfgang Dobberinas. This system is known as Dobberinas Triad. So, he is a German chemist, Johann Wolfgang Dobberinas. In 1817, he tried to arrange the elements based on their properties. He tried to arrange the elements into groups. He grouped the elements with similar chemical properties. The elements which possess similar chemical properties were grouped into clusters of three. Three elements which have similar chemical properties were grouped into a cluster called triad. Each of these cluster consisting of three elements with similar properties. It is known as a triad. He also said that when the elements in a triad are written in the increasing order of atomic mass, the atomic mass of the middle element will be roughly the average of the atomic masses of the other two elements. So, he arranged the elements with similar chemical properties into clusters of three known as triad, and he also said that when these elements in a triad are written in the increasing order of atomic mass, then the atomic mass of the middle element will be roughly the average of the atomic mass of the other two elements. For example, one of the triad made by Dobberinas was lithium, sodium, potassium. This was the simplest triad made by Dobberinas, lithium, sodium and potassium. The atomic mass of lithium is 6.9, that of sodium is 23 and potassium it is 39.1. So, look at this. First element has atomic mass 6.9, second one 23 and potassium 39.1. So, according to Dobberinas, the atomic mass of the middle element will be roughly the average of the atomic mass of the other two elements. So, we will take the average of these two, 39.1, you will get it as 46. 46 by 2 will give you 23. So, it is the average of the atomic mass of the other two elements. Okay, so you have to learn the triads given by Dobberinas. So, this is one triad, lithium, sodium, potassium. The other two examples are calcium, strontium, barium. This is a triad. So, atomic mass of strontium will be the average of the atomic mass of the other two elements. So, this is the second triad. Third one is chlorine, bromine, iodine. Okay, atomic masses of all these elements are given in the textbook. You need not by heart the atomic masses and all. The first one, that was the simplest triad. Lightest element was, the elements were there in the first triad. So you learn the atomic masses of those elements, lithium, sodium and potassium. Here you just learn the elements in the correct order. So these were the triads given by Dobberinas. Okay, first triad is lithium, sodium, potassium. Second one is calcium, strontium, barium, and the third one is chlorine, bromine and iodine. Chlorine, bromine, iodine. So these were the triads identified by Dobberinas. I hope you understood this. So elements with similar chemical properties were arranged in clusters of 3 and he called it triad, and he also said that the atomic mass of the middle element is roughly the average of the atomic mass of the other 2 elements. In the first triad, lithium, sodium, potassium, atomic mass of lithium is 6.9, potassium is 39.1. The middle element sodium, the atomic mass of the middle element sodium is roughly the average of the atomic mass of the other 2 elements. These were the other triads identified by Dobberinas. This you have to learn. You need not by heart the masses of all these elements, but the names you have to learn in the correct order. Okay. There was a demerit. This system had a demerit. Demerit can also be asked as defect. What was the defect of this system of classification? Then drawback, then limitation. Anything is asked, write the same point. Demerit, defect, drawback or limitation, whatever it is, same answer has to be written. The answer is that he could identify only 3 triads. Dobberinas could identify only 3 triads from the known elements at that time. At the time of Dobberinas, 30 elements were known. 30 elements were known at the time of Dobberinas, but he could identify only 3 triads. That means he could classify only 9 elements. 3 triads means 3 into 3, 9 elements. Only 9 elements were classified. He couldn't group the remaining 21 elements. So this system of classification was not found to be useful because most of the elements were not classified. Only 9 elements, 3 triads were identified. He didn't say anything about the other elements. Out of the 30 elements known at that time, he could identify only 3 triads. That was the demerit, defect, drawback or limitation of Dobberinas triad. Okay. So this system was rejected and we move on to the next one. Second classification, earlier attempt at the classification of element is Newlands Law of Octaves. Newlands Law of Octaves. It was made by an English scientist, John Newlands. He arranged the then known elements. At the time of John Newlands, 56 elements were known. He arranged the then known elements in the increasing order of atomic mass. You will see that in all these earlier attempts in the classification of elements, they are arranged in the order of atomic mass. What is the reason? Earlier it was believed that an atom is indivisible. Then atomic mass was considered as the fundamental property of an atom. Later only it was identified that an atom can be divided into protons, electrons and neutrons. Then the fundamental property is number of protons or electrons, that is atomic number. But at this time, it was believed that an atom is indivisible. So atomic mass was the fundamental property of an atom. So all these earlier attempts were made on the basis of atomic mass. So the known elements, 56 elements known at that time were arranged in the increasing order of atomic mass. He started the lightest element with lowest atomic mass, hydrogen, and started with hydrogen and ended at thorium with the symbol Th. He started with hydrogen and ended at thorium, which was the 56th element. He found that when elements are arranged in the increasing order of atomic mass, every 8th element possessed properties similar to that of the first. Every 8th element possessed properties similar to that of the first. he compared this to the octaves found in music. Octaves found in music. That's why he called it the law of octaves. That's why he called it the law of octaves. You can see Newlands octaves, the classification, only a part of the classification made by Newlands in page number 81, table 5.3. So, take table 5.3, page number 80, not 80, 81. So, on the top of the table, you can see the musical notes. In Indian system and in the Western system. Indian system, the notes are sa, ri, ga, ma, pa, da, ni. Seventh note is ni, and after that it is sa. Eighth note is actually a repetition of the first note. Eighth note is a repetition of the first one. Similarly, every eighth element had properties similar to that of the first. That's why he called it octave. So, he compared this to the octaves found in music and he called it Newlands law of octaves. Okay. So, on the top of the table you can see the musical notes. There are 7 notes in a scale. Indian system it is sa, ri, ga, ma, pa, da, ni, sa, and in Western scale, Western system also the notes are given do, re, mi. So, you can see it. And below that the elements are arranged starting with hydrogen. First element hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. Oxygen is the 7th element. Then comes the 8th element, fluorine, which had properties similar to that of hydrogen. That is the reason why hydrogen is placed below fluorine. Hydrogen is placed below fluorine. So, you should understand that below each note. So, below the note sa, the elements that come under the note sa, they should have same properties. Every 8th element, when you are starting with lithium, suppose you are starting with lithium. So, count it as first one, lithium. 8th element of lithium is sodium, which had properties similar to that of lithium. Okay. So, every 8th element had properties similar to that of the first. It is similar to the octaves found in music. 8th note is similar to the same as that of the first one. So, we start with sa, end with sa. So, every 8th element had properties similar to that of the first. So, he compared this to the octaves found in music and called it the law of octaves. I hope it is clear to you. Only 56 elements were known. Only a part of that classification is shown here. On the top of the table, you can see the musical notes in Indian system and in the Western system. Actually, it is the same. So, you can see that every 8th element had properties similar to that of the first. That is the reason why they come under the same note. All the elements coming under the same note, they will have same properties. Okay. So, Newlands law of octaves can be stated as when elements are arranged in the increasing order of atomic mass, every 8th element had properties similar to that of the first. When elements are arranged in the increasing order of atomic mass, every 8th element had properties similar to that of the first. That is Newlands law of octaves. But this system also had certain drawbacks. This Newlands law of octaves also had certain drawbacks. First one is that this system of classification worked well only for lighter elements. This worked only till calcium. This system of classification was applicable only till calcium, and after calcium every 8th element didn't possess properties similar to that of the first one. So, this system worked well only for lighter elements. It was applicable only up to calcium. After calcium, every 8th element didn't possess properties similar to that of the first. Second one is Newlands believed that there are only 56 elements existing in nature and no more elements would be discovered in future. Later on, several new elements were discovered and their properties couldn't fit into this law of octaves. So, that is the second drawback. Third one is that you can see, please look at the first column, that is under the musical note sa. You can see that cobalt and nickel, CO and Ni, cobalt and nickel are placed under the same note, in the same slot. In the same slot, 2 elements are placed. In the same slot, 2 elements are placed, and also under Ma also, under the note Ma also, you can see 2 elements placed in the same slot. So, he adjusted 2 elements in order to fit elements into his classification. He adjusted 2 elements in the same slot. In the same slot, two elements were adjusted, and also unlike elements were placed under the same node. I told you in the beginning, elements coming under the same node should have same properties, but unlike elements were placed under the same node. For example, this cobalt and nickel in the first column under the node Sa, actually they don't have any similar properties to other elements of the under the same node. Hydrogen, fluorine, chlorine, bromine, etc. They have properties entirely different from that of cobalt and nickel. Their properties are entirely different from that of cobalt and nickel. Actually, this cobalt and nickel possess properties similar to, their properties are similar to iron. Iron you can see in the last column. In the last column you can see iron. Actually, the properties of cobalt and nickel are similar to that of iron, but iron is placed far away from cobalt and nickel. So, this is the third drawback. What is it? In order to fit elements into his classification, Newlands adjusted two elements in the same slot, and also unlike elements were placed under the same node. That is the third defect. So, defect or drawback, demerit or limitation, anything comes, you have to write. Three drawbacks are there, three demerits are there. First one is it was applicable only up to calcium. After calcium, every eighth element didn't possess properties similar to that of the first. Second one is Newlands believe that there are only 56 elements existing in nature. No more elements would be discovered later, but later on several new elements were discovered whose properties didn't fit into the law of octaves. And the third one is, in order to fit elements into his classification, Newlands adjusted two elements in the same slot, and he placed unlike elements under the same node. Example is cobalt and nickel placed in the same slot, and they have properties entirely different from those of the other elements of that node in that column. Properties of cobalt and nickel are similar to that of iron, but iron is placed far away from cobalt and nickel. So, this system of classification worked well only for lighter elements. So, this was also rejected. So, the next system we will see in the next class. Thank you, children.